So let's look at the schematics, the device schematics of the WSN. So the networks of typically small, battery powered, and the devices are wireless devices. So we have onboard processing, communication, and sensing capabilities. So that give us the wireless sensor network. So let's look at the component. We have a processor, of course, is a low power processor. It's a limited processing. You cannot do a large processing on this kind of sensor, of course. Your storage is limited. So we need the storage, of course. We have a radio, we have processor, sensors, power, and so on. The radio is a low power, low data rate, and also the limited range. So we have a sensor to sense the data. Can be a microphone for the sound, can be cameras, can be a sensor for temperature, light, and etc. And of course the power. So let's look at the block diagram or mode. We have a battery, power monitor is connecting to the sensor board itself. We call it the mode, sensor mode. And you can see the different kind of sensor. We have a light sensor, humidity sensor, we have a temperature sensor, we have a and so on. And this is a picture of the WSN mode. You can see the revolution as well. The low power wireless mode with CPU sensor, low bitrate radio, and so on. The different type you can see: WEC, Rene, DOT, Mika, Spec, Telos, and so on. And you can see the evolution, the mode evolution. We are not going to go through one by one, but you can see some of the information here. You can see the year from 1998 to 2004, the name of the microcontroller. You can see the type, the RAM they had it from 0.5 to even we had sometimes 4 kilobyte RAM. This is a kilobyte RAM. You can see the power, you can see the storage, you can see the communication information like data rate starting from 10 kilobit per second until 250, and some other information about the power consumption and the programming as well as the sensor interface. So how basically did we get there? In this place, how the people think about the wireless sensor networks and what happened. Look at the story. So the first one is the advances wireless technology like MEMS, VLSI. As I said, MEMS is a stand for micro electro mechanical systems, or NEMS is for the nano one. VLSI is the very large scale integration. We call it VLSI. The technology is to putting a millions of the transistor into a small chip. We call it VLSI. So that is a technology that enable us to reach to the situation now. To be able to have a wireless sensor network. With the MEMS, VLSI, bandwidth explosion, changes in regulations, the government allowed to do that and so on. Cultural changes. Now the wireless devices are everywhere and the people are receptive to new applications. They welcome, especially with COVID-19, even the old people nowadays move to use applications, smartphones, online applications, and so on and so forth. The concept of network are ingrained in culture. And of course, the open source application, later we will see the open source is different with the free, but sometimes the people use open source as a free. They call it open, so they think that the open source is free. Open source meaning that the source itself, the programming codes and so on and everything are available to you to change. But sometimes you have to pay, sometimes it's free, not necessarily to be free. And of course, with the help of computer science, the operating system theory, network theory, inexpensive compilers, and so on, that all help us to reach to the place now. So what are the challenges that we discussed already? Maybe we can see again. Limited battery power, limited storage and computations. We are talking about the sensor network. Lower bandwidth and high error rates. Scalability, you want to have 1,000 or 2,000 nodes or sensor in a network. Another challenges is the network protocol design goals. They must operate in the self-configure mode. There is no infrastructure. So of course the protocol also will be different with the what you have in the infrastructure-based network. Limit memory footprint of protocol. Limit computation needs of protocol. Conserve battery power in all ways possible. You have to conserve because some of the processing, process, they will take a lot of battery. So the battery consumption is high. So we have to consider that as well. So now let's look at the typical features of WSN. We have a very large number of nodes, often in the order of 1,000. Asymmetric flow of information from the observer or sensor node to a command node. We will see the, how basically we can implement a wireless sensor network, and we will see the different type of devices as well. What we call it observer, sensor node, actuator, and so on. Communications are triggered by the queries or events. At each node, there is a limited amount of energy, which in many applications is impossible to replace or recharge. And the topology almost is static. We will discuss about the topology as well later. Low cost, low size, and low weight per node, prone to failure. You should consider that the probability of failure of the node is too high because of the physical environment, and you do not have access to cover them, or you do not have access to repair them. So prone to the failures. More use of the broadcast communication instead of point-to-point. We will see the different type of communication. We have broadcast, meaning that one can send it to everyone. So meaning that someone is sending the data out and everyone receiving. We call it broadcast. Point-to-point meaning from one PC, one computer, one laptop, one node to another node. We call it point-to-point. It's not broadcast anymore. The nodes do not have a global ID such as an IP number. We know about the IP addresses and so on. So the node in wireless sensor, they don't have the IP addresses. And of course the security, both physical and at the communication level, is much more limited compared to the conventional wireless network. In conventional wireless network, as I said, physical security. You can put your hub, your devices inside the rack, inside the room, you can lock it, and then no one can have access to it. But in the infrastructure-free network, you cannot do that. This is about the physical security, about the communication level security as well. So when you have a wire, you have an infrastructure, you can put a firewall, you can set the antivirus, you can have a different type of security level. But in wireless sensor network is limited. You cannot have all of these things. So when it comes to the design, you have to consider the design consideration like fault tolerance. So the failure of nodes should not severely degrade the overall performance of the network. As I said, the failure of the node is too high. So you have to design your network in such a way, if let's say half of your node are failed to operate, the rest of the node can work, and also your network can work properly. I mean, at least they can work. They should not depend on the others. If you know about the ring topology, for example, ring topology, if one node, if let's say you have 10 nodes in your ring, if one node failed, the whole network is failed. So no one can communicate with the others. So which is not suitable for wireless sensor network. The second design consideration is scalability. So the mechanism employed should be able to adapt to a wide range of network sizes. Let's say you have 100 sensor nodes and tomorrow you want to add another 100. Scalability meaning that you should be able to easily expand your network, add extra node or devices into your network without any problem. The third one is cost. The cost of a single node should be kept very low because you are going to have, let's say, 1,000 node in one physical environment. And also the power consumption. We discussed a lot about the power consumption. Should be kept to a minimum to extend the useful life of network. Let's say if the sensor node power consumption is very low, so it can last long. If a sensor node goes only for 1 month, it's very difficult. But it's go to 1 year, should be much better, right? It must be taken into consideration the hardware and software constraint, the sensor's location finding system, the antenna, the power amplifier, modulation, coding, CPU, RAM, operating. Everything you are going to put in a very small device. You should consider that as well. So when you design, you should design a hardware suitable for the sensor. On top of that, you are going to have an operating system as well. So that is about the software constraint. The topology maintenance. A topology you must choose that cope with the expected high rate of node failure, as I said. If you go for the ring, one node fail, so the rest of the network fail to operate. So the network is down. So no point of using such kind of topology. So you have to go for a topology that is suitable for the wireless sensor network. Deployment consideration. The pre-deployment mechanism and plans for node replacement and maintenance. So let's say if you can do that, you should consider as well. And of course, the transmission media, whether you are using the infrared or ISM band. ISM is the band allocated for the industrial, scientific, and medical purposes. So we call it ISM, industrial, scientific, medical. Whether you are using the ISM bands or infrared and etc. So about the environment, you have to consider the busy intersections, the interior of a large machinery. Let's say you want to put sensor in bottom of an ocean, inside a twister, surface of an ocean during a tornado. That is a kind of environment that you have. Biologically or chemically contaminated field, battlefield, beyond the enemy lines, home or a large building, large warehouse.